But you don't have to stop for the sake of recording. We're just using all of this as an ethics lecture. Don't do that. Everything that he's it's not, is it slander when it's true? Really? Well, okay, slander would mean that somebody has had an attack on your character that has hurt you. Everybody has a minimum opinion of your character. Nobody has a high opinion of what you're bringing to the table. No, I do not. I do not have a high opinion. Just point to a random verse in Revelation and he's the bad guy. Multiplies kisses? Well, okay, hold on. If we're really talking about who I'm mad at, it's Nathan. You know, he's a ranger, which means you should be attacking from the range. When both of our rangers kept getting one-shotted in melee range. We were playing D&D last night and we died on the final boss and these guys, it was two rangers. I was playing Tiefling Rogue. Man, how many kills did I have? I kept one shot in everything. It was so good. For Rogue? Oh, I'm using daggers. We're playing but we play on the new Demio. So we play Demio and Dungeons and Dragons Battle Marked. So I play in VR. Another guy played in VR. I think he played on Steam, and Blade plays on Steam. So we have multiple professors that play. Oh, we had a tank. Blade played tank. He kept dying in melee too, but he's supposed to die in melee. Oh, not there actually isn't a healer in Demio. Yeah. There's potions and then there's we do have a paladin type, but I would say in general, there's enough healing opportunities that you don't have like a dedicated healer when your maximum party size is 4. If you played it would make sense. Check it out. You can join we have a whole chat channel dedicated to it. But yeah, it was really an embarrassment. Although in Nathan's defense, you were pretty good for your very first time. Yeah. But Waleed disappointed. Especially with the whiff on the final boss. You can't do that. Exactly. You just have to have a natural crit. The guy's dead before the AoE. How hard is it to get a crit? All right, let's go to merge sort. All right, let's get to merge sort. Let's start a new project for this guy. How'd it go? Wait, which thing do I use on here? Do I use GitHub or do I use my other one? What's my GitHub? Is this it? I have too many GitHub accounts. What? Have you seen this new feature where it like talks to him? Like it. Let's see. Turn the digital crown for details. Oh, the only answer I got from the prank call or the whatever spam call was just hello. Oh, it didn't get me in. All right, here I'll log in with my Google then. Okay. It's the wrong account, but it's okay. There. Let me try going in real quick back into my GitHub one. Oh, I'm just in now. Whatever. Okay, so we're going to create a brand new project. We're going to pick our language is Java. Okay, so how did merge sort go? Easy?
Pretty easy. I think
Trivial?
Oh, yeah, absolutely. Oh, no, it actually,
All right, so
and yet he's fat.
yeah, you just
One of your carnal.
all right. So what we're going to do here is I want you to. I mean, obviously, this is being recursion. It's kind of hard to wrap your mind around, but I'm going to take an approach at this that is an approach that you should take with every project. The difficult part of this assignment is really finding where the front half and the back half of a list is. These are just 4 integers. So you can work out the math before you start making any recursive calls. Make sense? So let's start off by giving ourselves a list of random numbers. We'll give ourselves the ability to display that list because we're going to want to display it before it's sorted and display it after it's sorted, right? So let's create a new file. We'll call this guy merge sort.java. All right, and so we'll have class merge sort. All right, now remember in Java, we only have one file that has main in it. All programs begin and end with main. And I usually run this real quick just to make sure we have a working blah, blah. So there's my hello world. All right, so now we're gonna write our constructor for merge sort. Now merge sort, at least for right now, is gonna control an array, collection of stuff, okay? So we'll go ahead and we're gonna say, up top, we're going to make it private. We're going to say private int array. The data is what we'll call this. And then for merge sort, we're going to say public merge sort. Here's our constructor. This guy's going to take an int array, the data as a parameter. And we will set this dot the data equal to the data, the thing that was passed in. Let's also go ahead and give ourselves the ability to display that array so we have a quick way of looking at it. So we'll say public, blah, 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 void display. All right, and we want to go through every element of that array and display it to the screen. So we're going to have a for loop for int I is equal to 0. I is less than what? How many elements are in the data? You're just making up crap? Just 10? Are we writing a generic blueprint? How many elements are in the data?
Oh,
Dot length, number of elements. So it'll be this dot the data dot length. Legal access error apparently. Dot length, and that is a field, not a function. How do you know this is a field, not a function? A who? Well, couldn't I say this dot display? And that has, now that's a function. The parentheses. All right, so when we see something sitting there, it's either, if we assume it's not an error, if it has parentheses, it's either a constructor or a method. It's only a constructor if we're using it after the new keyword and it's the same name as the class that you're creating an instance of. Otherwise, must be a variable, or rather, must be a method if you're dealing with the parentheses. If you're not dealing with the parentheses, you only have one option. It's a variable. And variables at the class level are called fields, right? All right. So it's the length of, not this dot length, but it's this dot the data dot length. Oh, what? Ninja. I get enraged. This is yeah, that's the equivalent of what is it, road rage? All right, then we'll say I plus plus. So our goal is to go through this entire collection. And for each of those things, we want maybe kind of keep it on a single line rather than have it go all the way down. That might be hard to do. So we can either build a string up of these guys or just take advantage of the two different versions of system.out.print. Print doesn't kick it down a line. So print displays something and keeps it right after that on the line. So we're going to say this dot the data at bucket I, and then we'll add a little space after that guy just so the numbers are separated. At the end, we'll do a system.out.println. You can just use the one that takes no parameters, it'll kick it down the line, or you can send it an empty string, it'll kick it down the line. So now display, we'll go through our whole collection, displaying stuff one character at a time. Yeah. Is there any local variable here named the data? So if I left the this off of that, what it's going to look for is a local variable named data, and it's not going to find it. Okay. Since it's not going to find it, is it actually going to stop looking? Or will it find it? See, it's not going to find it locally because we don't have one to find locally. So it will jump up a scope and look up here. So this will work the way it is, but if we want to say the guy I'm talking about is the guy at the top level scope, the field owned by this class, we can say, don't even try to look locally. I'm talking about the field. This guy that lives up here. That variable is owned by this instance of merge sort, hence the this dot. Go ahead.
So in this particular example, it would be okay to leave the this off, but it's best practice to leave it.
That's true. Yeah, you could leave the this off and it would still work in this case just because of scoping rules. But it will technically be a little slower because it'll look in the local scope and then bounce up to the next scope. And keep in mind, as projects get more and more complicated, you might have many scopes inside of many scopes before you finally get up to the top level, when you could have just said, I know I'm talking about that guy. I also don't want to misspell it, so I'm going to say this dot. And, you know, so it's best practices to always use this, even if you don't have to. Yeah. You probably never use this if you don't have to, do you? You seem like the type that won't put this in there if you don't have to use it. You also seem like the curly brace on this, the opening curly brace on the top line too kind of guy. Yeah, it's not a compliment. All right, go ahead.
I was gonna ask if the final would do that for you, would like see.
Possibly.
If there is another one.
Yeah, so yeah, so online people, he's asking if we didn't use the this dot the data, would a compiler potentially notice at compile time that there isn't a local scope of it and either put it in, or as it's generating the low level language, make it as if it didn't have to look? Probably. It probably would. One of the jobs of compilers is to make your program look less bad. So whenever it can create low level code that once it's low level code, doesn't matter how bad the high level code was. So compilers have gotten pretty advanced. All right, so let's go ahead and let's build an instance of merge sort. Let's put some data in there, and then let's print it, make sure that's all working so we can start playing the game. All right, so out here, I'm going to go ahead and let's create a random list of numbers. And we'll just do it in main rather than putting it somewhere else. So in order to create random numbers, I'm going to have to import java.random, java.util.random. Ay, ay, ay. All right, I know, seriously, it's bad. So then we'll say something like random r is equal to new random. Now we want to create a collection. She seemed to want to make it 10 elements, so we'll make it 10 elements. So we're going to say int array AR is equal to a new int array of size 10. And actually, why don't we do this up here? Why don't we, well, no, we'll just leave it. It's fine. of size 10. I was going to create a variable at the top so we could change the size easily, but we can just change it right here if we want. All right, so now we want to loop through every bucket of that array and fill it up with a random integer. And just to keep things simple for us, why don't we make it a random number between like 0 and 50, something like that. All right, so we'll create a for loop for int I is equal to 0, I is less than ar.length. That's the number of elements inside of that array. I plus plus, then inside here, we'll go ahead and say AR at bucket I. So I will be 0, 1, 2, 3, 4. So it's going to walk through the elements of the array. So AR at bucket I gets a new random number that we want to be between 0 and 50. So that's r dot nextInt. I'm pretty sure Java random class. I think there's a version of nextInt that you can pass an int to, and it will give you a number between 0 and that minus 1. Let's just confirm. Next int. Yep, we have a bound 0 inclusive, the value exclusive. So if we want it to be 0 to 50, where's my code? Rage, snap. Hold on, where's the, seriously, I have too many tabs. There it is. All right. So we're going to go ahead. If we want, if it takes in a number and it gives us a number from 0 inclusive to whatever number we pass it exclusive, if we want 0 to 50, we got to give it a 51 to give us 0 to 51 not inclusive, which will include a 50. So we'll say 51. All right. So that's going to give us some number between 0 and 50 stored at bucket I in our array. All right. So now what we're going to go ahead and do is we're going to build an instance of merge sort with that array. All right. Because remember, merge sort that we wrote up here, this guy takes an array and as a parameter. All right. So we'll go ahead and build a version of merge sort. So we'll say, or an instance. So we'll say merge sort ms is equal to a new merge sort, and we'll pass it AR as our data. And then we remember that we wrote inside of merge sort a non-static non-static method. Non-static methods are owned by instances of the class. Static methods are owned by the class itself. So that means I need an instance of merge sort to call the display method. I just happen to have an instance. It's sitting out here in, it's called ms. So I can say ms.display. And now I should get my random list of 50 numbers displayed to the screen. A random list of 10 numbers between 0 and 50. All right, looking decent. All right, so we've tested it exhaustively. It always gives us a different list of numbers. All right, so the goal is now that we can call merge sort's merge function or merge sort function, and it does whatever magic is needed to sort this data. All right, so we're going to go into merge sort. And let's go ahead and we're going to say, we're going to make this guy, it'll be public, void, sort. Now, if we're sorting that data, why don't we need to pass that data in as a parameter to the sort function? If I come back out here to main and I say ms.sort, why don't I have to pass it in AR here? Good. Yeah, class already knows about it. That class was built in terms of AR. So that was passed into the constructor here in AR, whose job it is to construct an instance of this guy. And he took whatever array you passed in and he set it equal to his field, this guy up here. So as long as we're in the class called merge sort, we have access to that array. All right. So we don't need to pass that in. That's why we said, don't give me anything. I have everything I need. I have the data. I know how long it is. Let me just take care of sorting this for you. All right. So out here, we would call ms sort, and then we probably display it again, hopefully proving to ourselves our merge sort has done its thing. All right. Now, for right now, just for testing, I'm going to turn those displays off because as we are, I mentioned a few minutes ago that the challenge of this is making sure that we can confidently find the first half, the beginning and end of the first half, and the beginning and end of the second half. And I gave you a hint last time that length divided by 2 is not middle, right? Because sometimes you're working on the right half of the list. And that's not the middle, is what it comes down to. All right, so we're going to call sort. Sort already knows about the array. So now what I'm going to do is I'm going to create a function called private, or a function that is private. And we're going to call this guy, it's going to be private void, well, let's call this, we'll just call it MS. It's a private internal function. All right, and MS is going to take a int begin and an int end. It's going to have 2 pieces of information that it needs to know. Okay, it already knows about the array. What we need to do is we need to tell this guy which portion of the array are we paying attention to, right? When I first call this guy, when I make my first single call, I'm calling it on the entire array. So begin will be 0, end will be length minus 1. Or depending on how you do your math, it could be length for where the end is if you say that it's non-inclusive. But we'll do length minus 1. So for sort, we're going to go ahead and we're going to say this dot ms, and we're going to pass it 0 and this dot the data dot length minus 1. That is the portion of the array that we want to pay attention to the first time. The entire array. Okay? Now, what does it mean? Remind me, what does it mean for something to be private? Ah! It's like you just went full Hulk in class. All right, go ahead. Sorry.
Isn't private, correct me if I'm wrong, private when it's only accessible by the class?
Let's go with sort of.
Also correct me if I'm wrong. Public is like if you have
If they think I won't.
a.
It's like we'll just roll with that one. Go ahead.
Public, like if you have a house that has a bunch of rooms and you have a tool, you can move that tool from your room, but private, that tool has to stay in one room.
Okay. So at the end of the day, private means that we can only access this function if we are inside of this class called merge sort. We are currently in a class named merge sort. We have a private member of this class. Remember, all classes are made up of fields, constructors, and methods. All right. And all those things come in the form of public, private, or protected, if we really want them to be. Remember, protected is the one that kind of helps us with the inheritance-y stuff. Private helps us with things that do not need to be publicly exposed. So what's the rationale for us using private here? Well, out here, I create my instance of merge sort. I pass it the data I want to sort, and then I just say, look, sort it. I don't care how you accomplish it. Just sort it. That guy doesn't need to know about all the internal workings, right? So we're going to keep those internal workings, those cogs. We're going to keep those private so we don't see it from the outside. Remember way back in coding 1. And everybody remembered all of that, right? We memorized it. The telephone. Oh my gosh, Carnival, that's awesome. Oh, is it? Oh. Yeah, we were talking about the difference between procedural languages and object-oriented languages, right? And we said really the difference between procedural and object-oriented is organization. People try to make it this really complex thing, but all that we really did is we said, hey, you're coming from a procedural language like C, and you've been starting to hit a wall with using structs in C because they don't hold functions. No problem. We have this brand new animal for you. It's called a class. It's just like a struct, except instead of just holding variables, it can also hold methods and constructors that allow you to set those variables. It's called a class. It's perfect. It's great. It's a piece of Tupperware. So what did we say with we had the procedural version of the telephone is this giant pile of wires, right? We see everything, all the details. We can fish through, we can get to the phone parts that we recognize and we can use it as a phone. But man, there's a lot of stuff there that we didn't have to deal with. We still saw it. Once we take all that crap and we stuff it into a box, now we have an instance of an object. It's an instance in this case of a telephone. Now, what do we see on the outside of that phone? We see the things that we actually need to interact with in order to use that object. For instance, with merge sort, we at the very least need to be able to tell him to sort. We also need to be able to tell him to display. But we don't need to call these other things from the outside. There isn't a button for calling merge sort with the or MS with the correct begin and end. We're going to handle all that internally where they don't see it. That's object-oriented programming. Put all the wires in a box, poke holes where you need to access it from the outside. Otherwise, everything else is private or protected if you have an inheritance structure. All right. So as we become more advanced programmers, we want to start writing our code in such a way that it's kind of self-policing. I do not subscribe to Python's, let's call it, completely stupid approach to the Python's I use it all the time. I keep telling you, but this language is a joke. So anyways, Python doesn't let you do public, private, protected. It just says, hey, figure it out on your own. You police yourself. No, that's okay. But when you have big teams of people working on something, you don't want them accidentally calling your wrong function externally because your code now has, 120 methods in it, all being accessible from outside the class, even though really only 3 of them actually need to be. Allow you to make it private, cut it off. The best way you can do that in Python is you can make them pass in like an API key or something like that. And you only give that key to the people who should have access to your functions externally. It's just it's a dumb language. All right. So anyways, we come into MS, we have begin or end. Now we know that something is trivially sorted if begin and end are the same, right? That's our first wall in merge sort. If I have a begin and I have an end and they're the same number, I don't have to do anything special. Okay, so we're going to say if begin is not equal to end. Right? We're only going to do anything inside this function if begin is not equal to end. Good enough? Otherwise, begin, end, same value, we'll just end. It's whatever, go ahead.
Clarify. Like points where
the portion of the array we're looking at. So when we first called merge sort right here, we've said, I want to look all the way from the beginning, all the way to the last element. So the very first call is, let's sort the whole thing. Then we're going to start dividing this guy up. So if begin is not the same thing as end, and we can even put a little else in here if we want, just for some color commentary. We can do like a system.err.println A1 list is sorted by definition. Something like that. So if we get into this else, that means we were dealing with something that was a 1 list. We don't have to do anything. We're just going to give a little nod to the error stream saying, this is a 1 list. I'm not going to touch it. But otherwise, if it's not a 1 list, we need to do our magic in here. Go ahead.
Every single time you want to print something. Like, wouldn't it be nice if there was something called print?
100%.
Like,
So you could write your own library just called, carnival.java. You create your instance of it. So then everything, in there is just carnival.print. But now you're still printing some extra crap. Carnival++. All right. So if begin is not equal to end, that means we have something to do. And if we have something to do, we need to calculate some stuff, right? Because if begin is not equal to end, what do we need to do? We need to call merge sort on the first half, and we need to call merge sort on the second half. In order to do that, we have to know where the first half and the begins and ends, and where the second half begins and ends. That makes sense? All right. So we're going to say int begin 1, int end 1, int begin 2, int end 2. All right. So in fact, actually, let's change this slightly. We're going to call this guy left begin, left end for the left half of our list. And we'll call this guy right begin and right end. All right. So we know that begin and end are not the same. So we know we need to make more calls to the merge sort. The first thing we need to do is we need to figure out the beginning and ending of the left half. Where is the beginning of the left half? Is it at 0 or is it at whatever begin is? Remember, merge sort is going to be called a whole bunch of times. Begin and end are where are we currently looking at in this array, right? The whole thing. So the beginning of the left side will be whatever is the first value in the portion of the array we're looking at. So left begin will be begin. All right. Now, left end. This is where the math gets a little sketch, right? So we might be tempted, especially when we're just thinking about, oh, well, our first call is 0 to 10. And we know if I have a list with 10 elements in it, the middle's here. Could be bucket 4, could be bucket 5, depending on how you decide to do your math. But we know that's the center. So we could be lulled into saying, oh, well, the center of this guy is the length divided by 2. Well, that's actually not the center. It worked this time. But what happens if you are making a merge sort call to the right half of this list? From bucket 5 to bucket 9 for it's 0 to 9 for a 10 element list. All right, so you got 5 to 9 over here for your right half. Well, 5 to 9 over here, if you go off the length of the entire list, right? Well, now you're going to say, well, my middle here is this guy, 5. That's not the middle of this part, right? If you say, well, I'm going to take the length of this, well, we could say, oh, well, there's 5 elements here, something like that. So 5 divided by 2 is 2.5, but we're going to truncate it so it's 2. So actually, the middle of this guy is over here. That doesn't seem right either. How do we actually calculate the middle? This is the one complex part of this. It's not hard math, but how did you actually calculate the middle of the portion of the list that you're looking at that is represented with the beginning being in begin and the end being in end? What is the middle of that? That's, yeah, it's, well, certainly not n divided by 2.
Or end dot length.
End is an int. It doesn't have a length. Well, it's a primitive type. Primitive types can only hold values. I mean, I presume everybody in this room did the merge sort assignment, or at least went to ChatGPT, right? And I did give you a hint last time that this would be the one thing, that it's not the length of what you're looking at divided by 2. Nobody can tell me what the math is? Huh? Oh. So, okay, so nobody critically thought through this enough to figure out where the middle of the list is? This is what's happened to higher ed. This. I mean, guy's a professional at drinking Trulies, but this can't do, this is just addition and division. The middle is end, well, doesn't matter if we say that first. Begin plus end divided by 2. So if you had over here you had 5 and 9. Okay. 5 plus 9 is 14. Divided by 2 is 7. Is between 5 and 9, is that the middle? 7?
I was gonna say that.
Yeah, were you? This is what happens. You're not using your full noggin to solve these problems. Oh, this is going to be a.
You
Go
the
ahead.
easy way, you just find another way to do it.
Go ahead.
Why is that different from n divided by two?
Why is begin plus n divided by 2 a different function than just n divided by 2?
Well, I mean, is it begin plus n?
Well, let's just look at our example. If begin in our example we've been using here is 5 and end is 9. 9 divided by 2 is 4.5, which is 4. So 4 is a different value than 7. So at very least, it's different in that the answers are different. But also, end divided by 2 only takes into, basically pretends like you're always starting at 0. When the beginning of our list is not always 0. Sometimes we're making our very first call to the right half of the list and we're nowhere close to 0 here, right? We started this guy off at bucket 4 or 5, however you did your math. Does that make sense? All right, so this is the magical math that it seems like I guess nobody did. You know, the middle of the portion of the list you're looking at is whatever the beginning is plus the end divided by 2. That gets you the middle of those two numbers. Go ahead.
You know, look, wouldn't you also have to round that down? It's,
Why don't I have to round this?
no, I'm saying, wouldn't,
I'm asking you why I don't have to. The answer is no, I don't have to, but why? Yeah, this is integer division. So that means when we use divide, it does integer division. So something like 4.5, when doing integer division, just becomes 4. What about 4.9? What would 4.9 become? Still 4. Okay, because integer division, integers do not have the capability of holding floating point numbers. So it's not doing any sort of rounding magic. It's just saying, hey, you gave me a 4.5, I'll store a 4. Get away from me. It's just that type of thing. If we did have a floating point value here, or we did something like divided by, I think if we do, well, it probably would still work there. If I made this guy a double, it would do the floating point math because it's going to store the value into something that can hold a decimal point. All right. So begin plus n divided by 2 is the left end. So where's the right begin? That plus 1. If that's our middle, and we're going to say, well, you get to decide. You can decide, is my middle, is it part of the left list or is it part of the right list? Let's assume it's part of the left list. This would be your right, my left. Okay. Then we just need to add 1 to it to get me here. If it's the beginning of the right list, which is, we actually put it at left end, so we really have to add 1 to it. So right begin is left end plus 1. So left end stopped here. The beginning of right is the guy right after that. Plus 1. So my left begin is whatever that is, all the way up into left end. Right begin is the guy right after this guy. So it's plus 1 of that. And then right end is equal to end. That's the second half of our list. All right, we good with this? Go ahead.
So, trying to find the of the left side.
Let's just write it out. So we make our original call to merge sort where begin is equal to 0 and end is equal to 5. Actually, we were saying its length, so it's 6. The length of this whole thing is 6. So we're always making the assumption that we go up to, but not including end in our current example. All right. So when I'm trying to find the middle of this, I'm going to say begin, which is 0, plus end, which is 6 or 5, depending on how you want to do your math. So our left begin is equal to 0. Here, let me put it out over here. Our right begin, I'm sorry, left begin and left end is what we're doing next. Left end is equal to begin 0 plus end 6. 0 plus 6 is 6. Divided by 2 is 3. So that puts us right here. So doing the math that way, our left end is a little bit further than half. That's okay. We've divided it up. Probably not the math I'd use. The math I'd use is I'd pass in an end of 5. Notice here when we first called merge sort, we passed in a 0 and we passed in the length of the data minus 1. So if the length of my data is 10, minus 1 is 9. So in this actual example, end would be 5. The length of this whole thing is 6, minus 1 is 5. So left begin is begin. Left end is begin plus end. 0 plus 5 is 5. 5 divided by 2 is 2.5, but 2.5 doesn't fit in an int, so that truncates to 2. So left begin is here. Left end is here. Right begin is equal to left end plus 1. So that's a 3. That's the beginning of the right half. Right end is equal to right end is equal to whatever end was, which is 5. All right. So then what do? We make a merge sort call on the left half, 0 to 2. Now let's pretend we've already gone through and done all that. All right. Let's just pretend we're like on our second merge sort call at this high level. So if I'm on our merge sort call where we say, where's my text? So when I say we're going to call this dot ms, passing it requires a beginning and an end, and I say I'm going to pass you right begin and right end. So this is the second half of that list. All right. That means that our begin and end in this case is 3 and 5. That's our begin and end for this call to it, because we were calling it on the right half of this guy. So we can say left begin. Let's just steal this whole guy. This is good enough. So left begin is begin. So that's going to be a 3. Left end is 5 plus 3, which is 8, divided by 2, which is 4. Right begin is 4 plus 1, which is 5. Right end is 5. So if we just imagine this part of the array, the left half is that guy. The right half has a beginning and ending both of 5. That's a 1 list. So when we make that call, it'll bounce right back out because it was a 1 list. It's already sorted. There's no better way of ordering 5. It's already in order. All right, so this makes sense, this begin end thing. All right, so the begin end thing, that's important that we get those numbers right. So what we can do here is just for our test, we can go system.out.println, and let's give it LB colon concatenated with left begin, concatenated with left end, colon, concatenated with left end. What? Is it awesome? Where's my double semicolon? Oh, thank you. All right, so I'm gonna kick this down the line and keep going. We actually have to have the concatenation up here. I think it's a thing. So then we'll say, so that's left end. So now we're gonna say right beginning, colon, concatenated with right begin, concatenated with right end, concatenated with right end. All right, so we're going to go ahead and print that out. So after we've figured out left begin and left end and right begin and right end, we can print all those things out. Oh, you know what? Actually, I just came up with a better way of doing this. We're going to dump all that. It's fine. This is gonna be clear. Same values are going to print. What we're going to do is every single time merge sort gets called, we're going to say sorting begin versus end. Will tell us what part of it we're looking at. So we'll say system.out.println. We're going to print out begin. Well, here we're going to say sorting section concatenated with begin, concatenated with to, concatenated with end. All right, so every time we call merge sort, it's going to print out the portion of the array it's sorting. So the first time it's going to print out, I'm sorting the whole thing. Then it's going to say I'm sorting the left half. Then it's going to say I'm sorting the left half of the left half. If we have a left half of that, it's going to say sorting that, blah, blah, blah. Then finally, you're going to see it start working on the right half. So let's make our two merge sort calls. So we're going to say this.ms. So this is a recursive call, right? And ms is a private function. Am I allowed to call ms here? I'm inside of the class called merge sort. In fact, I'm actually inside the function called ms. It is extremely local. All right, so we're making a recursive call. This.ms, we'll go ahead and pass it our left begin and our left end. This.ms, we'll pass it our right begin and our right end. All right, make some sense? Call merge sort on the left half, let it go ahead and do its thing. Then once that guy is done completely, we know the left half will be sorted once we've written our merge step. Then we'll start working on the right half. All right, so I have my two calls to it. I have my original call. So when I call sort here, it gets the ball rolling by calling merge sort on the entire list. Then I say I'm sorting the entire list. Then I'm going to say, well, if begin and end are not equal, then I'll calculate my new begin and ends. I'll call merge sort two separate times. I'll actually see the first time print out here, and then I'll see that guy's first time print out before we ever get to the second one. So let's watch this play out. Still calling MS. All right, so we're sorting 0 to 9. Then we're sorting the left half, 0 to 4. Then we're sorting the left half of that, 0 to 2. Then we're sorting the left half of that, 0 to 1. Then we're sorting the left half of that, 0 to 0, which is actually a 1 list. So it's sorted by definition. So then we're sorting the right half of that, that's 1 to 1, which is a 1 list. So we bounce back up. Okay, so now we'll be merging those two guys together. We haven't done our merge step yet. So then we're to the right half of that left of the left half. So it's 2 to 2, what's a 1 list, 3 to 4, then 3 to 3, which is left half of that 1 list, then 4 to 4, it's the right half of that 1 list. So now we're back to the sorting 3 to 4. Now we're finally at the original second call. Let's sort the right half of the original list, 5 to 9. Then the left half of that, 5 to 7. Then the right half of that, 5 to, the left half of that, which is 5 to 6. Right half of that is, that's the left half and then left half. So 5 to 5 is a 1 list. 6 to 6 is a 1 list. So we sort those. Now we're going to sort the right half of 2 calls ago, which is 7 to 7, which is a 1 list. Then we'll sort the left half, 8 to 9. Then the left half of that, 8 to 8. The right half of that, 9 to 9. which is a one list that will bounce back up after we've done all our sorting. And after that's all done, we should have we should have a sorted array. Okay, so are we good with we're calling that function all the right times with the right beginning and ends? We good with that so far? That's the hardest part of this problem. It's what we just did. Make sure you have your beginning and endings correct for your two calls in the merge sort. All right. So we spent all our time so far just proving that. This merge step is actually a pretty easy step. All right, so let's go ahead and let's write our merge step. Now we can write it inside of merge sort if we want, or we can write our own function, maybe called merge, that takes a begin to end and works on that. So we can say private void merge, and this guy is going to take a int left begin, and int left end, and int right begin, and int right end. Oh, hold on. Can I do this? I can do that, right? Ha ha. Can I do something here? Can I do that? Ha ha. Ninja. All right. So, hold on. I'm lost. Right end like that. All right. So when I say merge, what I'm saying is I want to create a new array that has the same number of elements in it as this array. So that means I need to go from left begin all the way to right end. So if left begin is 0 and right end is 9, 9 minus 0 is 9 divided by, or plus 1 is 10. That's the full list. Okay. If we're just dealing with the left half, 5 to 9, 9 minus 5 is 4. 4 plus 1 is 5. So 5, 6, 7, 8, 9. That's the length of that side too. All right. So, so we know the length of this if we say, so int length of section is equal to right end minus left begin plus 1. That gets us our length of the portion that we're dealing with. All right. So even if I'm dealing with the right half of it, from buckets 5 to bucket 9, that guy has a length of 5. Because I need to create another array down here of the right length so that as we're merging this guy, we have a place to put our winners. Then after we have all our winners, we can copy the contents of this back over up here. So our original array contains the sorted version. All right, so I'm going to go ahead and I'm going to create a int array temp, and this guy is going to be it's going to be a new int array of size length of section, like that. So now temp is the place I'm going to keep track of my winners. Now I know that I have I'm going to have temp.length number of winners. But chances are we're on two different counters. So temp is 0 indexed. So if there's 5 elements, it's 0, 1, 2, 3, 4. Even though my competition is 5 through 9, potentially. All right, so I need to make sure that I'm keeping track of where I am on the two different lists. Okay, so we want to keep track of the left pause. So we're going to say int left pause is equal to left begin. So we're going to make left pause point at the very beginning of the left half. And then we're going to have int right pause, and he will be equal to right begin. So he's going to be pointing at the beginning of the right half. All right, make some sense? All right, so now what we want to do is we want to keep track of a couple of variables. We can do it inside of a for loop if we want, or we can just kind of have our own variables for I guess for doing this. So what I'm going to do is I'm going to say int pause temp is equal to 0. That's where the first winner we're going to place inside of temp will be at bucket 0. Okay, int pause. Let's call this section. The first element we'll put there is going to be at left begin. So when we go and copy this stuff back over, we're going to be putting it at beginning of whatever section of the array we are, all the way here for that number of things. How many things? Length of section number of things. All right. So now we're going to go ahead and we're going to place some number of winners. How many winners? Length of section number of winners. Or I can say temp.length number of winners. Those are both the same value. That is how many races are going to be run. All right, so I'm going to create a for loop for int I is equal to 0, I is less than, pick your poison, temp.length, I plus plus. Wow, I didn't get my curly brace made because of one little stupid typo. Now I know what his life is like. It's not a compliment, not even close. Weird, he took it as a compliment, isn't it?
I think he just likes being,
Pathetic,
yeah,
short and pathetic, really.
he is pretty short.
He's like 5'4". He's claiming 6 foot. There's no way that's going on. All right. So, anyways, we need to detect temp.length number of winners. And the competition is between the dude currently at left pause and the dude currently at right pause. And then when we find our winner, we move the correct guy. Okay. So the first thing we want to do is we want to ask, are both of those guys pointing to legal places? So if left pause is less than or equal to left end. So if left pause is currently pointing to some place on the left half of the list, left end points to the far right side of the left half of the list, right? So as long as left pause is somewhere legal on the left half of the list, we still need to consider that runner in the race. All right. And right pause is less than or equal to right end. So as long as that guy still points to a place on the list, if both of them are pointing to a place that's on their respective lists, then we need to ask which of those two is smaller. Okay, we know they're both legal. So we're going to say if this dot data, was it this dot the data? Yeah, this dot the data at bucket left pause is less than this dot the data at bucket right pause. Okay, so that asks, is the runner at position left pause, is he less than the runner, faster than, I guess, in my thing, is he less than the runner at position right pause? Which of these two guys should come first in our list? If this guy is less than this guy, he's going to be placed. If he's not less than him, he's either equal to or greater than, so we can just place this guy. All right. So if the left guy wins, we're going to say temp at bucket pause temp, or we could say bucket I actually. Temp at position I is equal to this dot the data at bucket left pause. And since left pause won there, we're going to say left pause plus plus. So we decided left pause versus right pause. This guy's our winner. So we'll go ahead and place him into temp, and then we'll have him move over one for the next race. Make sense? All right. So otherwise, else, if the left dude didn't win, the right dude must have, right? So we're going to say temp at bucket I is equal to this dot the data at bucket right pause. Did I? Or you just think I spelled that wrong? You're pretty confident, right? All right. So I did it on purpose, by the way. It was a test.
Yes.
All right. So if the right guy is the winner, we'll place him as the winner. We'll say right pause plus plus to move him along. All right. So we're done with that if statement. So if both of those guys are legal places, we want to detect who the winner is. If they're not both legal and we're still in this loop, because this loop knows the exact number of things that we're placing. In our example of 5, we have 5 winners to declare, right? Any way you cut it, this for loop is going to go the exact number of times that we need to place something. That's why temp is the length that it is. We calculated temp based on the beginning and ending of the portion we're working with. So if we didn't get into that if, that means one of the 2 sides is illegal. So we need to figure out which of those ones. So we're going to say else if left pause is less than or equal to left end. So if left pause is not off the end of the left half, then he must be the legal one, right? So if he's we know we're not here unless one of them is illegal. One of them has run off the end of his list. So if left pause is still on his list, he's the guy that's going to be the default winner of this race. So if we're in here, the left guy wins by default. So we'll say temp at bucket I is equal to this dot the data. You mean pause temp? No, we're going to use that probably in our next loop when we copy this stuff over. Yeah, right now we know where we are in temp by I. I is keeping track of it. It's possible I won't use it, but we'll see what we run into. All right, so I know if I'm in this else if that the left guy is the winner. So we're going to say that left pause is the position in the data that we're going to declare the winner by default because he's not running against anyone. And then we'll say left pause plus plus. Else, if I'm still here, if I'm here, that means the right guy is the only one that's legal. So I'll say temp at bucket I. Did I spell temp right? Bucket I is fingers and tremors. I hate it. This dot the data at right pause, then right pause plus plus. All right. So that's our merge step. Yes, it looks like a bunch of lines, but it's a for loop with some if statements in it. We're not asking hard questions here, right? All hard programs are made up of easy parts. If you were to crack open the source code for Linux or for Windows or whatever, you'd see for loops, you'd see if statements, you see ints, you see all the same stuff. You would just see millions of lines of it. All right. So what I want you to see here as I'm going about doing this is I'm talking you through the process that I would go through to do this. Let's get the beginning and end right. Let's feel confident in the beginning and end before I start making recursive calls, because recursion is going to be difficult to debug. All right, so after this for loop, temp holds the elements in the correct order, or in unsupported operation exception, apparently. Why did you pop that up as like a possibility?
Good. Throw it at Carnival.
This laptop's worth more than Carnival's life. It's like a $6,000 laptop. I guess that's another point. What's up? All right. No. All right. So temp holds the correct values right now. So all I have to do is copy them back over to the correct part. So I'm going to say for int I is equal to, what do we call it? Left begin. Left begin. I is less than or equal to right end. This is the portion of the array we just sorted. I plus plus. So in this case, I is our index through the data. We're going to say this dot the data at bucket I gets the value of temp at bucket temp pause. This value right here, or pause temp. The value we created up here. I'll go ahead and move this and create it right beforehand so you can see it before that loop. This guy is going to let us keep track of where we are inside of temp. Since we are placing bucket 0 into bucket 5, bucket 1 into bucket 6, bucket 2 into bucket 7. So we have two different things we need to keep track of. So this guy equals temp at bucket temp pause. Then we'll say temp pause plus plus. And we could have done this inside the for loop. For loops let us have multiple variables, but whatever. All right, so we'll go through that for loop. It's going to go and just copy everything over from temp. So now that portion of our array that we called this guy for should have everything in order in and of itself. So now we'll get our elements. Let me make sure our print statement is out of here. So I'll just comment out this print statement. And then we need to make sure that after we call our merge sort twice, we're going to say this dot merge, and we want to pass it begin and end. The portion of the list that we're currently dealing with. Actually, merge is taking left begin, left end, right begin, right end. That's fine. We're not going to recalculate those. So merge is going to take left begin, left end, right begin, right end. So that'll be our merge step. We'll just make a call telling it where the left half of the list is, where the right half of the list is. It's going to go ahead and merge them into a sorted version into temp. Then we'll copy that back over to the portion of the list that we were looking at. So we're going to display our values. Then we'll go ahead and tell it to sort it, which calls merge sort the first time on the whole list, and then does our whole recursive dealy. Then we'll display it again, and it should be sorted. Temp pause error, cannot find symbol. Temp. Where was that? Temp, this dot data. Oh, pause temp is what it's called. Where were you on the debugging there? I tried to trick you and you failed. It was that sorted? And there it was beforehand. I guess I forgot to take my one list crap out. I can just comment that. Oh, look at that, right on time too. All right, so that is merge sort. What do you think?
I think mine was better because mine had one function. Two functions.
And what function?
You had to make two functions to do it.
Well, I could have put all of merge into. That's fine. Yours could be better.
Yeah.
I did mine live in front of an audience. You want to do that next class? All right. Questions, comments, concerns? I'll put this code up. I'll put a link of it up so you can walk through it. This is a difficult thing, but hopefully today helped you saw the process by which I walked through this. All right. Front row of chapel, you're all invited if you would like to join us. No pressure, but we'll be sitting there. Well, there is pressure, but not that much pressure.